Okay, so today we're going to talk about similar polygons and ratios in those similar polygons. So what does it mean to be similar? Good. The same shape, but what? Not necessarily the same size, okay? So it's the same shape, but they're going to be different sizes. One's going to be bigger than the other, but everything about them should be proportional, okay? Everything should grow in the same in each dimension. All right. This is the symbol we use for similar. It's that little tilde symbol. So when you see that, that means similar. That was terrible. Like that. Okay? It's called the tilde. So anytime you see that, that symbol means being similar. So the first thing I want to do is, as I look at these two boxes here, these two rectangular prisms, I want to know, are these two similar to each other? Okay? And they look like it, but here's the way we're going to test for sure to see on that. Okay? So this 7 is talking about this dimension right here. It's talking about how tall that one is. Okay, so on the other one, which one matches up to that? Which one corresponds to that on the bigger one? 35. The 35, okay? So I'm going to say the 7 is to the 35. Okay, 7 corresponds to the 35. So the 7... whenever it grew to a 35. All right? Now, the 5 is talking about this dimension right here. So what number corresponds to that on the other one? The 25. So the 5 corresponds to the 25. Okay? And now the 6 is this dimension. What number matches up to that? 30. The 30. So the 6 goes to the 30. So what I want to know now is this proportional like what we talked about yesterday? Are all of these equal? Or in other words, did all of the sides grow by the same scale? Did they scale in the same way? Okay? So top 7 divided by 35 in your calculator and get a decimal on that real quick. What is 7 divided by 35? It's 0.2. Okay. Type in 5 divided by 25. 0.2? Is that what it is? Okay. And then 6 divided by 30 is 0.2. So are all of those equal? Yes. So what that tells me is that they grew in the same way. Or another way to think about it is like this. To go from 7 to 35, what did that multiply by? What did it scale by? Well, that's kind of going the other way. But going from 7 to 35, what did it get multiplied by? By 5. From the 5 to go to the 25, what happened? It got multiplied by 5. From the 6 to the 30, what happened? So did they all get multiplied by the same number? Yes, they did. They all got multiplied by 5. Now, if it would have been like multiplied by 5, and then this one is multiplied by 6, that would stretch it out to where they wouldn't be similar anymore. But since they all scaled by the same number, these two are similar to each other. Okay? So that's the question here is, are these similar? And yes, these two are similar to each other. Okay? Next one, I want to know if these two quadrilaterals are similar to each other. All right, so let's think about this. What does the 6 match up to? 3. The 3. So the 6 is to the 3 as the 4 is to the 2 as the 8 is to the 4. As the 8 is to the 4. Are all of those equal to each other? Yes. What's 6 divided by 3? 2. What's 4 divided by 2? 2. And 8 divided by 4 is 2. So all these are equal. These are similar. Okay, and again, the other way to think about it is like this. To get from 6 to 3, what do you do? You can think of it either way. So you just multiply it by 1/2. Or in other words, this is just half of this number, right? Is 2 half of 4?
Yes.
Yes, and is 4 half of 8?
Yes.
Yes, so it's scaled properly. Everything's scaled in the same way, so that's good. Okay, on this one, I forgot to put this in here, but we're going to assume that this is similar to this, okay? And so I'm going to use that fact to find the length of this side EF right here. All right, so I'm going to start off with two sides that I know. So what matches up to this 9? The 12. Okay, so I'm going to do it like this. The 9 is to the 12 as...
12 is to 16.
Okay, I could do that, but that doesn't help me because I'm looking for the x.
So x is 20.
So the 9 is to the 12 as the x is to the...
20.
Good. Yep, and now it's the same thing we did yesterday. We're just cross multiplying. We're just solving for x. And so we get 12x equals...
X equals 15.
Okay, good. 9 times 20 is 180. Divided by 12.
So then that x would be 15.
Yep. So x is 15. Okay, on the back. So we have these two cars. Okay, and it's kind of hard to tell what's going on here, but so the width of this car is 1.8 meters.
The length of it is 5.
And the length of it is 5. And then on the smaller car, the width is 6.3 centimeters. And the length of it is what I'm looking for. That's the x. Okay, so the 1.8 it goes to what number? 6.3. So the 1.8 is to the 6.3.
X is to 5.
Okay, and we've got to make sure we go in the same order
5 is to 8.
as the 5 is to the x. So see how the 1.8 was the top number here? The number that's on the same one has to be the same one here. They have to match up. So this is to this as this is to this. And then we just solve from there. Okay. So 6.3 times 5 is what?
31.
It's 31.5. And then 1.8 times x is 1.8x. X equals 17.5. So this is 17.5 centimeters. Now, some of you may look at that and say, well, look, this one has meters right here, and this has centimeters. Do we have to make those the same units? And the answer is no, you don't, because this is working proportionally. And since it's working proportionally, it's going to work out the same way. If you did convert those to where they were in the same units, like if you converted the meters to centimeters and worked it out, you'd see it give you the same thing. It'd give you 17.5. Okay? And if you think about it, 17.5 makes sense with this being 17.5 makes sense with that being 6.3 as those kind of relate to each other. So we're good there. All right. I'm going to skip that next one and let's look at this one that has the multiple choice here. So triangle ABC has side lengths of 14, 8, and 10.4. What are possible side lengths of triangle DEF if triangle ABC is similar to triangle DEF? ABC similar to DEF. Okay. So this side going to this side, 14 to 28. What does that scale by? What does it get multiplied by?
2.
Okay, that's just multiplied by straight up 2. Now, if it's going to be similar, all the other sides have to scale by that same number. Okay? So if you scale 8 by 2, what do you get?
16.
You get 16. Whoops, sorry. Not 20. So is the one up here and the one in A going to be similar to each other?
No.
No, because the first one scaled by 2 and the second one's going to scale by something more than 2. So these two are not similar to each other. All right. Next one, so 14 to 35. Okay, so to get that, I think it's 2.5 you have to multiply by. Okay, if you multiply 8 by 2.5, do you get 16? No. So those are not similar either. All right. Next one, 14 times 2 is 28. But then same thing, 8 times 2 is 16, not 20. So that's not it. So hopefully it's the last one. Okay, 14 times 2.5 is 35. 8 times 2.5 is 20, and 10.4 times 2.5 is 26. That's it. So that's what we're looking for. To be similar, they have to scale by the same number in every dimension. If there's one dimension where it's off by even just a little bit, then they're not similar anymore. Okay, on this last one, state if these are similar. Now we've got to think about what matches up to what. So if you'll notice, you've got the 70 right here, and on this one, the 70 is kind of in a different place. So we're going to kind of have to flip this in our minds to make these match up. So basically, this bigger one, I need to turn it 90 degrees. So what is the 8 going to match up to? 8's going to match up to the 36, because you're going to have to take this and turn it 90 degrees to make this 70 match up to this 70. So actually the 8 matches up to the 36, and the 7 matches up to what?
32.
The 32. So I want to know, are these similar? Okay, so type in 8 over 36 in your calculator and get that as a decimal real quick. Point what? 2 repeating?
Yes, sir.
Okay, what is 7 over 32 as a decimal?
121.
Okay, are these two equal to each other?
No.
No, they're close, but for this, close doesn't matter. It's got to be exact. So those are not equal. That tells me that these two are not similar to each other. These are not similar. Okay? So basically we're using the idea of a scale factor, of it being multiplied by some number to get to the other to determine whether they're similar or not.